Hello again YouTube from the CNC cave. I've been working on this CNC conversion for a couple of days now during the holidays, and I was a couple of days sick, actually not feeling too good today either, but need to get stuff done, so I'm at the garage making some connections to this. I really like the controller. It's very simple to get it running. The manual is actually good. It's decent English. It has enough information that you can use to set up the controller. And yeah, I already have gotten the axis to move, and it was a couple of days ago, before I got a little nauseous, I got the homing sequence done, so now I can home the machine, and it uses micro switches now because I couldn't find my other switches. God damn it. Well, the contactless switches. Brain block, can't remember what they were. The inductive switches. Couldn't find them, so I'm using the Omron micro switches for now. Well, I bet it's for now as forever, as long as they work, because I'm too lazy to change anything. But yeah, now I can let's move the machine from the home position, and now when homing the machine, got the zero return, x-axis first, and enter. It drives to the switch and backs out from the switch, and then backs out to the next Z indexing pulse. So it's not so crucial how closely it recognizes the homing switch, if it's some tenths of a millimeter off, because when it's backing out to the indexing, if it's less than one revolution of the encoder off, then everything is fine. It's always in the same exact position, and only the encoder resolution is the factor that sets how accurate it is. If it's more than one revolution off, it'll error out of indexing pulse. So as long as it's within one revolution, then everything is okay. So it should be accurate enough. And then we go return, Z-axis, and enter, and it does the same for the Z-axis and backs out to the indexing, and now the machine is homed. So that works. Everything moves. Turret. We have tool 2, and let's go to tool 3. It's overshooting because I'm driving the turret motor with relay now, and it's not reversing the motor to lock the turret. But all I wanted to see that the logic is working the way I figured it should work. I had a little help from a fellow YouTuber, can't remember his name, sorry, but he has configured this similar controller to the Emco Turn 50, I think. You can find him very easily in YouTube. But he had gotten an example macro program from the manufacturer, and he was kind enough to put it out on his webpage so people can get a hold of the program and see how it's done. He's using different encoder setup and different logic, but comparing the original tool changer logic and his logic, it was very easy to compile a tool changer macro for this turret. It's very easy to do. It's actually ridiculously easy. I can show you how it goes. Let's go to diagnosis, and in the diagnosis screen we can see I use tool inputs from tool 1, 2, 3, 4 as the 4 bits that I need to read the gray code encoder from the Emco. Emco uses PNP system and I use on this NPN, so I need to reverse the tool positions, but that was easy. But yeah, I'm just reading these tool positions. This controller can use 8 different switches for tool position sensing, and you can use 8 tools and each of them have its own switch. But I just use the inputs to read the encoder. So we're in diagnosis, let's press N and then we go tool macro, and here's the macro. First line is a local variable that stores the tool number, and the second is the tool requested, tool aim 301. So if 301 equals 1, so tool 1, then it outputs positive to the Y18 relay output and starts to rotating the turret as long as it sees the tool positions on X 0, 1, 2, 3. It sees inputs on high, low, high, high. So then it stops, opens the relay 18 and stops the turret and puts position reached on bottom of the screen. Pauses for 500 microseconds and goes to line 10. End if. And the line 10 is at the end of the tool macro. It says this line, pauses, and the tool variable is same as the tool requested, and current tool is the requested tool, and status info tool change is finished. Pause for 300 milliseconds and display refresh for the tool number. It refreshes this display and returns to the beginning of the program, waiting for the next tool. So now we had tool 3 and we could see the tool output. Takes a little while. Then we go tool 1, 2, tool 3, and it wanted to see low, high, 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 and we could see in the IO that it was low, high, high, high. Let's go back to diagnosis, and here is the low, high, high, high. And so that's how the tool macro works, and we can We can put any tool number. Whoops. Back. We need to go to manual mode and then we can get MDI. And let's put here something like tool 707 and delete the numbers and press cycle start. And as you can see, it overshoots because it doesn't reverse the current to the motor. But yeah, tool 7 and tool 7. It works, which is nice. So now I only need to connect the encoder for the spindle and connect the variable frequency drive to the I/O, and then it's just finishing the door conversion to get it to slide the other way, and then it's ready. Yeah, here you can see the mess of wires. It's a small machine, so all the wires are pretty long. I need to mount them somewhere. And here's the control board, the I/O board, and it's showing the same inputs for the tools. And then there's opto isolation board for the tool changer encoder, and granite devices, servo amplifiers using AC servos, and they got encoders on them, so it's closed loop system. And there's the VFD that needs to be mounted and connected to the I/O. Then I just need to make a fan for the fan to cool the servos and the electronics, and close this enclosure and tidy up the wiring, and the machine is done. But yeah, if you have any questions, put them down below, and you all stay safe and have a nice day. Bye.